All right, we are back. So to see what happens when you raise a power to a power, use the order of operations. Okay, see what happens when you raise a power. So when it's talking about a power, it's talking about this right here, right? So that's our exponent. This whole thing, this is our power, and it's being raised to a power. So it's a power being raised to another power, and it's just separated by that parentheses. So first, let's go ahead and think about this. Inside the parentheses, right? Order of operations says parentheses, exponents, multiplication, division, addition and subtraction. So we got to do the parentheses first. So what is 4 to the third power? Well, that is the same thing as 4 times 4 times 4, right? That is this. Okay, and that is being raised to that second power. Okay? So now, what does this mean? 4 times 4 times 4 raised to the second power. Well, that means 4 times 4 times 4, right? That is our base right here. That's our base. And then it's multiplied by itself 2 times. So 4 times 4 times 4. Like that. Okay, so see where we started, 4 to the third, and it's being raised to the second power. Well, 4 to the third is the same thing as 4 times 4 times 4, right? 4 multiplied by itself 3 times, and that's being squared. Well, what does this mean? Well, this means you take this base and you multiply by itself 1, 2 times. Now, we just have a bunch of 4s that are multiplied, right? And so we can write that as an exponent. 4 times 4 times 4 times 4 times 4 times 4 is equal to 4 to the 1, 2, 3, 4, 5, 6th power. And that would be the answer there. Okay? Now, I love for you to show all this work. However, there is, just like the other ones, the product rule and the quotient rule. Product rule is multiplication, right? Quotient rule is division. A power to a power is called, that's the cheat rule called the power rule. Okay? And what it says is to raise a power to a power. So to raise a power to a power, where's my pink? To a power here, okay? And it's really important to know how to identify. We have that parenthesis that just separates both of those powers. It says keep the base. Okay, I can do that. So we're going to keep the base of 4 here. We keep that base of 4 and multiply the exponents. Oops, sorry about that. Multiply the exponents. So 3 times 2, and show this work, equals 4 to the 6th power, which is what we got up here. It's the same thing. So whenever you have these power, you just multiply the exponents, and that's how you arrive at the answer. Okay, so let's look at a few problems. Raising a power to a power. Let's go up here. Right? So we have 7 to the 5th raised to the 3rd power. This is a power being raised to a power, so we keep that base and just multiply those exponents, which is 7 to the 5 times 3, which is 15, 7/15. Okay, let's go to the next one. We have 8 to the 9th raised to the 11th power, so we're going to use that power rule again, which states keep the base, and 9 times 11 equals 99. All right, ooh, this one looks fun. We have some negative exponents. So 2 to the negative 7th raised to the negative 2, we just do what it says, right? Keep the base and multiply the exponents. So negative 7 times negative 2. a negative times a negative, and then we just do our integer rules, right? A negative times a negative is a positive, so we're left with 2 to the positive. 7 times 2 is 14. That's not that bad at all. All right, how about this one? We have x to the 10th raised to the negative 6th power. We just keep that x. We can do it with a variable, no problem. And then we just go 10 times negative 6. And we keep that base. A positive times a negative is a negative. 10 times 6 is 60. And then we always want to write with positive exponents. So it'd be 1 over x to the 60th power. Perfect. Okay, I want you to try E, F, and H. Okay, I want you to try E, F, and H. Actually, yeah, E, F, G, H. Try them all. You could do it. All right, I will see you in a little bit. Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out those problems. When you get done, press play, and I'll talk to you in a little bit. Okay, let's see how you did. So we have 5 to the 4th raised to the 2nd power. We keep that base and multiply those exponents. 4 times 2 is 8. If you got that one right, woohoo! Okay, let's go on to the next. 6 to the 7th raised to the 9th power. We keep that base of 6. Multiply those exponents. Make sure you're showing all that work. 6 to the 7 times 9 is 63. Boom, shakalaka, there we go. This one, okay, we have our base here, the 2/3 raised to the 12th power, all raised to negative 3. So the power rule says we keep this base, and 12 times negative 3 equals, positive times a negative is a negative. 12 times 3 is 36. Okay, now this one's fun because whenever you have a fraction, what that means is each thing in this fraction is raised to the negative 36th power. So this is the same as 2 to the negative 36 over 3 to the negative 36, okay? And to write this as a positive, I'm going to have to flip this one to the bottom, right? So it's 2 to the 36th power, and then I'm going to have to flip this one to the top. So because it's a negative and I want it to be positive, so 3 to the 36th power. And then if I wanted to write it as one thing, I could go back and go 3 over 2 raised to the 36th power. And that would be the answer. So I don't know what you got, but if you didn't get this, then go ahead, or you maybe got it a different way. I want you to go ahead and erase what you have and then kind of write the progression of here, how we arrived at the answer. All right, perfect. Let's look at H. So we have y squared raised to the negative 20th power. So that's going to be y to the 2 times negative 20. A positive times a negative is a negative. 2 times 20 is 40. And then we just rewrite that negative and make it a positive by flipping this to the bottom. And there we have it. If you got all of those right, you did a wonderful job, and I'll see you next time.